Alright people, we are going to be looking at factoring a different kind of polynomial, sorry, and that is one where the coefficient is not 1. In other words, we've been doing so far polynomials like this, where the lead coefficient of x squared is just 1. All we had to do was find our magic, in this case, negative 6 and 2, and that's how we got our answer. But the problem starts when the leading coefficient is not 1, something different, and let me show you why. Take for an example this binomial product here, where we have 3x and 2x as the lead terms, and watch what happens when we do the expansion. Here's the first step. Okay, and then we combine like terms in the middle, and you can see the challenge this time because now if we're using the magic number method, we're trying to find two numbers that multiply to give 20 and add to give 23, but none exist. And so that method doesn't quite work. But it does if we change it slightly. And so here's how we're going to change it now. What we're actually going to do is we're going to look at the product of 20 and 6, 120. This is, in fact, what we've been doing so far. But because our lead coefficient has always been 1, it's been 1 times something, and which is just the same thing. So this is still the same thing we've been doing. It just doesn't quite look like it. So here we go. So 120. Let's look now at factors of 120. And try to find some that add up to 23. So 2 and 60, 3 and 40. We're getting closer. Those are 43, 4 and 30. Okay, those add up to 34. Okay, now let's just stop for a second. We already know which ones are going to be, right? Because it's going to be 15 and 8, but let's keep going anyways. 5 and 24 is total 29. 6 and 20 is 26. And 8 and 15 obviously is the ones we want, 23. Now this should look really familiar because this is the way we started doing these today in class. In other words, we broke apart that middle term into these two terms here and factored by pairs, which is essentially what we're going to end up doing. So this is what we're going to, I'll lay out the steps for you how this is going to work. It's very similar to yesterday's class or today's class, depending what time you watch this video at. Okay, so first what we're going to do is we're going to find our magic numbers. The product is not going to be C. It's going to be A times C. Whatever that lead coefficient is, times a constant term. The sum is still going to be the middle coefficient. And then just like we did in the first class we did this, we're going to break that middle term out into the magic numbers and then factor by pairs. Okay, so let's do one here, and you can see how this actually works, and hopefully it should look familiar to the previous lesson here. Okay, so here is an example here. So let's follow those 3 steps in. Start by finding our magic numbers. Magic numbers are going to have a product of 24 because that's 2 times 12, which means they're going to add to 11. So can you think of those numbers that multiply to give 24, add to give 11? And it's 8 and 3. Now we cannot do that shortcut now where we just skip right to the answer. We have to break out that middle term. This is what it looks like. Okay, so now I've rewritten that middle term 11x as 8x plus 3x, my magic numbers. And now I can factor by pairs. And I'm just going to look at those two there, and I see that I have a 2x that is common to both. A 2x squared divided by 2x is just x. 8x divided by 2x is 4. Okay, then I'm going to look at the second set of numbers there. I'm going to try and find common factors here, and I see that 3 is common to both, so I'm going to factor out 3, leaving me behind x plus 4. And then I notice that x plus 4 is a common factor there, so I can factor that out front. X plus 4 times whatever's left over, which is 2x plus 3. Okay, and so the factoring by pairs thing we did at the very beginning of this chapter comes in quite handy there. Like I said, it would. Okay, well here's another one then. 12x squared plus 43x plus 10. Same method. Find the magic numbers that multiply to give 120, add to give 43. Hopefully you can see that 40 and 3 are our magic numbers. So let's rewrite that that middle term into those two numbers, 40 and 3. Okay, and let's factor by pairs, starting with the first set right here, we see that let's see, it looks like an x is there. What else? Looks like a 4. 4x is common to both, so I'll pull that out front. 12x squared divided by 4x is 3x. 40x divided by 4x is 10. Okay, and 3x and 10 over here, nothing's common, so I'll just factor out a 1 just to make this really obvious. 3x plus 10. You'll see that 3x plus 10 is common to both, so then I factor that out front, and that's my answer. Okay, and then 4x plus 1 is left over. There you go. And again, you can do the check by multiplying it out using the distributive law, and you should get the original question back again, which we do. Okay, so there it is there. Here's one I'd like you to try on your own. Okay, I'm going to give you 3 seconds to look at this one. You want to first of all try and figure out what magic numbers multiply to give negative 120 and have a difference of 19. I'll give you 3 seconds to do that. Okay, and hopefully you found out that the magic numbers are 24 and negative 5. From here then, I wait another 3 seconds and you can finish factoring that using the breakout method. Okay, so here we go. Let's first of all break out that middle term into our magic numbers. Okay, and if you're wondering if it matters which order you write them in, like should I have done negative 5x plus 24x, it doesn't matter. It all works out in the end, okay? But we did it this way here. Let's go ahead and factor by pairs. So looking at 6x squared and 24x, I see 6x is a common factor, leaving behind x plus 4. Okay, and then from the second set, I see I have a negative 5x, negative 20, so negative 5, I'm going to factor that one out. So factor out a negative 5, leaving behind x plus 4 again. And again, you see that x plus 4 is common to both, leaving behind 6x and negative 5. So 6x minus 5 times x plus 4, or x plus 4 times 6x minus 5. Doesn't matter which one you do. All right, so here is the one that I want you to try for homework. Bring it to school tomorrow, or on, I guess this would be the next day whenever you come back to school. I see you, and we'll go over this one in class. All right, there you are, 8x squared minus 26x plus 15. Factor that out, bring it to school tomorrow, and we'll go over it. See you then.